Hi there guys, I'm Chris Bowden.
And I'm Paul Kidwell.
Welcome to the Geek Group, where today we're doing a follow-up video. I did an autopsy, which you recently saw, where we took apart the ceramic heater dingus right here, and we've got it wired up to our giant Flex Lab, the standard electronic time company power supply. This has been our big set power supply, and I never get to play with this. So I figured I'd hook it up and do a whole thing. And we waited until you got here, so that we could do a basic on resistors.
Okay.
Because one of our most popular videos ever was talking about the basics of contactors and relays. Mm-hmm. So I want to do some more on this kind of thing.
Okay.
Like really fundamental, simple stuff that we never think about, but people need to know.
Well, I gathered a collection here that we can
Yes,
play
we've
around with.
got decade boxes, and we've got meters. We got my good meter. We got a megger. This just came in. We just got this donated.
Megger.
Yes. Have you ever played with one of these?
No, I haven't.
It's a mega ohm meter.
Okay.
And I'll talk about it later.
All right,
but
you do that.
All right. So I got this thing.
Okay.
And we took this apart in a video. We autopsied it, and it had these inside.
Okay.
And these are dusty on one side, so you know the input side for the fan. But they're just little ceramic plates. This is the resistor. Mm-hmm. There's no nichrome wire or anything like that.
Well,
So I was like, that's cool. We should hook this up. So we've got the Pyrex plate out of the microwave oven autopsy that we just shot. Mm-hmm. And I figured we'd fire this up and check it out. I'll put them all fuzzy side up because the fan was on the, no, flip it over.
It is fuzzy.
That's
side.
fuzzy, okay. It's cleaner now.
I really
We'll put
wonder
this on
about
here.
that being right side up or not. But,
What?
well, when I saw this,
Well, the fan was on the back,
I understand that,
so
but
that sucks the fuzzy
it
through.
looks like the contact point is there.
I think you're right.
I think you got the...
I think they're in backwards. But that's easy to fix. All right, so
Remember how that was originally?
What?
The piece that you're pulling out right now.
This?
That goes on, does that go on top?
Yeah, I think that goes on top and this goes on bottom.
Okay, so pull that up.
I was working on that.
Okay, so this guy goes on the bottom.
I don't know why you got to be like that.
I always,
man.
It's what I do.
Nothing but nice to you.
Okay, so there's all those.
Get it in there. No, it's
There's something going on.
yeah. You're a little senile, I think, is really the fundamental problem.
Yeah, I think that looks better.
Yeah, that's way more better.
Yes.
Okay. So while we got this open, let's measure the resistance.
Okay.
Okay, because I've got
Here,
my meter. This is like my official personal meter here.
Let's get one.
I'm going to set this to ohms.
And what do you get?
I get 80 ohms of resistance.
About, yeah.
Okay.
I'll buy that.
So we'll put them all together. Now at this point, that's 4 of them in parallel.
Right.
Okay. And we'll put this in. Now you hold that down.
Yeah.
Okay. And I'll go over here and measure this. And we get, with 4 in parallel, we get 40 ohms.
40 ohms. That doesn't work mathematically, but...
Well, that's what the meter says. Yeah, I got 36.5.
Yeah, you'd have to measure each one to find out exactly what each one was and then do the math.
I don't care that much.
Okay.
So, all right.
So we got 40 ohms.
We got 40 ohms. Now I'm going to put the part here on. Okay, now I'm going to hold that down. I'm going to go over here, flip on our power supply, and we're going to see what happens. Now you're going to hold this for safety because we're going to want to be able to hold that up so people can see it. That, and I'm going to dump a lot of electricity into it, and it's going to get really hot and possibly light on fire. So for safety, you should hold that, and I'll turn the knob.
Okay.
Okay, you ready? Do we want to meter voltage on this while we're doing it? We can do that.
If you can get...
We can totally do that. Watch. Can we just pull these boots off?
No, well, the other.
Okay, I'm going to clip, well, I'll put this on this side. I'll put this on this side. See, I lined up all the black wires like a professional. Mm-hmm. Now I'm going to measure AC volts, and I'll just set that where everybody can see it. Okay, now we've got 1 volt. Ready?
Yeah.
13 volts. Okay, there's 60 volts. So you're halfway there.
We're halfway there.
Anything happening?
Not that I'm warm.
It's warm.
Yeah, well, bring it all the way up.
All right. That's 103 volts. We're not getting a full 120 out of it, but we're definitely getting some voltage. And it's starting to smoke.
It is?
Yeah,
Yes, it is.
That would be smoke, Paul.
We're cooking the, and I think I'm getting a little bit of a red glow. I'm not.
It's definitely, you blow through it and your hand on the back gets hot. Like it's making heat.
Mm-hmm.
So we've got.
I was expecting that to glow a lot brighter than, I was expecting
Well, you're
it to
also
glow.
shining it through at all the lights in the cameras and
true.
stuff. So.
I'm not seeing any glow.
All right, I see no glow.
No glow. I'm actually surprised. I was expecting
Okay,
like.
I'm gonna turn that off. Voltage is at 0.
Okay, this thing is like warm now.
Well, duh, it's a heater. I planned ahead. That's why I had you hold it for safety. All right,
you mean
take
your
that.
safety?
Well, really, that's what matters. That's the important part.
Okay, there you go.
You'll heal. You're a rugged man, Paul. Very rugged man. All right, so we know the voltage.
Yeah.
120 volts, give or take.
Right.
We know the resistance, it was 40 ohms.
Correct.
What's the amperage that we were drawing at that point?
To figure that out, you need to use something called Ohm's Law.
Okay.
And it's a mathematical formula where volts equal amps times resistance.
And this works in like 3 different ways.
But you can solve for any variable you need to know.
Okay.
Now, I've drawn a little pyramid that I use to remind myself, but basically the part you need, you cover, and what's left shows you the formula you need.
Okay.
Like if we want to know current, it's E over R, so volts divided by resistance. So we had, what was it, 103 volts is what you saw, and 40 ohms was the resistance we measured. So 103 over 40. So that's what? I don't do simple math in my
I can't do that in my head.
2.5.
Yeah, a little
bit.
give or take.
Give or take, about 2.5 amps.
See, I liked it a lot better when I said 120 volts, because that makes the math way easier.
Yes, 103 volts divided by 40 ohms equals, well, about 2.5 amps.
Okay.
Now, there's another formula for power, which
Now, we got to explain what each of these
Okay.
are to people.
E is...
Because there's no V up there.
That's right. E is a representation of voltage. Voltage is electromotive force, which is where the letter comes from. Resistance is measured in ohms. They named it after the unit after the guy. And they use R for resistance. That's ohms, symbol omega. The letter I was being used for a couple other things, like the square root of -1. A was being used for other things, like acceleration. They use I to represent current.
Okay.
Now, I represents other things as well, so I don't know how they got ahead by doing that, but I has always been current.
Okay.
Now, there's another formula. Got another triangle.
Everything's triangles. Like we could do the food pyramid, we could do Maslow, we could, yeah.
But power, expressed in watts,
Okay.
is amps times volts. Yes, and you can do a V for the E and an A for the I. But so we got 2.5 amps. We have 103 volts. So 103 volts times, what was it, 2.5 amps is approximately 250 watts. You want to go? You're going to...
I was going to like do the real numbers, but we can just go with yours.
All right, well...
It's a little low.
So, yes, I was expecting higher. But, what?
Your number is a little low.
103, well, yes. Okay, fine.
That was, yeah. All right. So that's the formula. This is the theory. This is the math.
Right, this is the math. And like similar with this, if you want to know power, it's I times E. If you want to
And
know volts,
for
it's I
99%
times
of the
R.
things in the world, you can do it about this fast and loose. I mean, just like, well, it's about 2.5 amps. Okay, we need a 3 amp fuse for that and life's good.
Exactly.
Okay. Now let's look at some of the other, because I had you go around and scrounge up a bunch of different resistors.
Yes.
We had a whole of like 10 minutes of prep time for this video. Okay, so what is this?
That's a 1/4 watt, and I haven't looked at the color code, so I can't tell you what the value
That's
is.
something we should talk about.
We'll do that in a
Okay.
sec.
Now, this is half watt?
That's a 1/2 watt.
Okay, now look at the difference.
It's bigger.
Yes. Why is it
And
bigger?
More power.
Is that a 1 watt?
That's,
Or 5
I
watt?
think that's a 2 watt.
Okay.
I think this is a 1
Now,
watt.
let's talk about watts.
Watts. That is a, yeah, I can't.
Well, let's
quite
go with
read it.
these because these are all similar type. That's a wire
All right,
round, so
that's
it's a little
wire
different. So, okay, why are these resistors different sizes?
Okay, depending on how much current you're going to put through them, they're going to dissipate however many watts based on our mathematical formula here.
Okay.
So you want a resistor that's wattage is at least, if not more, than what you're expecting to draw through it. If your resistor is a lower wattage than what you need, it will get very hot very quickly and possibly burst into flames. There's a bunch of different things that resistors are made out of. These are carbon film, meaning there's a little ceramic stick in there with a carbon layer over it.
It's like a spring. It's a helical winding.
It's a winding, yes. And based on the length of the winding and the thickness of the windings, they can vary the resistance. They have others that are carbon composition, which is just a slug of carbon inside the resistor.
Are those the white ones?
They're usually dark brown, like Bakelite.
Okay.
Those were a long time ago. Those were one of the
okay.
first type of resistors.
What are the
made.
ones, and you didn't bring one out for this, which kind of bites, but the ones that it looks like a white rectangle box?
I looked for one of them. Those are, it's a ceramic resistor,
Yeah.
and it's wire wound. Literally, you got a ceramic stick in there with a piece of wire wrapped around it.
Okay.
And the length of the wire sets the resistance.
Okay. I didn't know how
The
those
point I
worked.
wanted to make about the carbon composition ones, when those burn, you get a carbon arc.
Yeah.
It can be rather spectacular.
Yeah, we killed a bunch of them setting up Thumper.
Yes, we
Stomper.
did.
Stomper. We had them out here, pff, and
Yeah,
it was
that
really pretty. And
it was spectacular.
if there's video of that, you totally have to put it in for B-roll.
Yes.
That would be cool.
Yes.
All right, so we've got, this is a wire around resistor.
Yes, now-
which is wire around a thing.
And these are all wire
This is a little
wound.
mini pipe bomb.
That's what it looks like. But what's it say on there?
It says,
When you get bigger, they actually put words to tell you.
yeah, this says CP1, 1%, 200. And that's it. So I'm guessing 2 ohms, 1% tolerance. And from its size, I'd say a watt.
Now, they get bigger. These are 91 watt, 150 ohm.
Okay.
And there's,
And there's
three
of them stacked together
They're
in
all wire
parallel.
them in parallel.
So now hang on, there's 3 of these in parallel. What is our rating on that?
Okay. The formula for resistors in series is you just add them up.
Okay.
When you put them in parallel, you can see we have an electrical connection tying them together here. When the current comes in, it's got 3 different paths to go through. And this here, all 3 are the same. So the simple thing to do is take the resistance and divide by the number of the ones you have. So 150 ohms, 3 of them in parallel, divide by 3, it's 50 ohms overall. All right. If the values are different, you got to do a little math to get your total.
Now why not just put a 50 ohm resistor on there then?
You could, but these are 91 ohms, so you'd need a 91 watts. You would need a 270 watt resistor to get the same power rating as what these 3 do. You can use multiple resistors to give you a higher power rating.
Okay, and I want to touch on something because this is something a lot of people ask about, and this is a really good time to cover that. All the stuff that we're talking about with resistors and hooking them in series and parallel applies to a certain type of inductive load, speakers.
Speakers.
So
yes.
let's say you have your speaker cabinet and you've got a tweeter, a mid-range, and a woofer.
Right.
And these each have 2 wires out the sides. Now, there's 2 different ways to hook these up. Now, this varies widely, but generally, it can be assumed that a given speaker for this kind of stuff is 8 ohms. That's by far the most common. So this is 8, this is 8, and this is 8. Now, there's 2 ways to hook these up. We could bring our positive in and go here and hook them up in series like that. Okay, and that's series. Or we could hook them up Did I spell parallel right?
Parallel. Looks good to me.
I always get the L's weird. All right, or parallel. Okay, so red wires are the series where it goes through this speaker, then this speaker, then this speaker.
Right.
So if any one speaker blows out, and they will rather quickly like that, no sound comes through at all. Or we could hook them up in parallel, which is probably better because then you can have a system where if this speaker blew, the other 2 would still work, and you could even balance it out like our awesome balanced MDH audio system where the tweeter on this side's blown and the woofer on the other side's blown, so they balance out.
Lovely.
Oh, it's great. That's what we get for buying 80 speakers.
Okay.
But these are all 8 ohms. Now, our amp, like most amps, is going to say on the back of the amp, it wants 8 to 16 ohms, okay? With 4 ohm minimum. And that's a hard minimum. Because the lower that number gets, the harder the amplifier has to work.
The more current the amplifier has to provide.
Yep. So, with this very common real-world situation, what is our amp going to see?
Well, in your series arrangement, your 3 resistors, your 3 speakers will add.
Okay.
So that would be 8 plus 8 plus 8.
Okay.
24 ohms.
Yes. Because that's 8 plus 8 plus 8.
All right, now.
And this, the amp will handle. It'll be okay. It'll.
Well, it's 8 to 16 is what you wrote down.
That's usually what amps want, is like 8 or 16, or 4 to 16. But if you're going to load an amp out of spec, if you give that amp 24 ohms, it'll live. It'll sink 24 ohms all day long and be totally cool.
Yes.
You won't kill the amp that way. However, the other way.
Yes, you're going to run into trouble. I need to write a formula.
You
on
do.
board. Yes.
You have to do math for this one.
Yes. Now, the formula, the raw formula for a parallel circuit is called a reciprocal sum.
Okay.
It's, we'll call them R1, 2, and 3. So it's 1 over R1 plus 1 over R2 plus 1 over R3, and then you take the reciprocal of the whole thing.
Okay.
That gives you your total resistance. Now, if the 3 values are the same, 8 in this case, it's 1/8 plus 1/8 plus 1/8, that's 3/8. And you take this reciprocal of that, so it's 8/3. So it's the resistance of 1 divided by the number of them if all the values are the same.
Okay.
So 8 divided by 3, you want to do the math on that? It's going to be 2 point something.
Now, I want to throw you a curveball on this.
Which is way below your hard limit.
Okay, so we're gonna end up down at like 2 ohms.
2 point something or other.
2 and change ohms.
Right.
Okay, at this point, the amp dies.
Yes.
We kill the amp.
You overcurrent thing. You probably blow the fuse.
Yeah.
It's current limited, so usually, if you got a good one.
Now, what happens? And get out your calculator because I want to get real numbers on this. If maybe you got this speaker from your parents' old stereo system, you got this one at a garage sale, and your brother blew up a stereo system in his car, so only had 1 speaker left, and this one's a big romping thing, but it's only like 4 ohms.
Okay. If you decrease your resistance, you're going to increase your current. So I can tell you your resistance is going to wind up lower than what it was. But you had me turn my phone off.
Well, you can mute it, you know.
I did, but it still
We're making a
vibrates.
video. It's like a rule. We have to mute our phones.
Yes. I'm not buying.
There's
If I'm having to turn my phone on, if it rings, I'm not buying.
There's a rule during video shoots that if your phone rings during a video shoot, you have to buy drinks for the crew.
Yeah. But you're instructing
it's fine.
me to.
That's,
okay.
Yep, it's all my fault.
Hey, 4G. Okay. Let's see. Where's my calculator? Real calc. There we go.
Real calc.
Okay, now, it's an eighth, and a quarter.
Okay.
Well, in all honesty, I don't really need the calculator for that because a quarter is 2/8. So rather than the reciprocal of 3/8, it's the reciprocal of 4/8, which is exactly 2 ohms.
Okay.
So you got it right on that one.
Okay.
So,
but that speakers going together.
Yeah, lowering the resistance of one component here is going to lower the resistance of the overall circuit.
Okay.
Even if it was you wired it in series, you would go down to 20 ohms here. It'd still be lower.
Cool. Now we can go back to this. Because that was the one that people were going to comment on. Because if you start talking about resistors and that, people want to know about speakers.
All right.
So now we go on to these.
These are...
I've never seen these before.
I dug them out of the electronics lab. They were...
When you picked these out, I thought they were the old battery packs.
I thought they were battery packs. I thought they were diode stacks. This one here is 80 ohms plus or minus 0.1%, which means it's a precision resistor, and it's 25 watts. So this is precision resistors are rather expensive.
Well, this is 3/4 watt at 0.5%.
So it's a 0.5%.
But it doesn't tell me the ohms.
Really? Yeah, it does.
Where?
See where it's got that 4R00?
Yeah.
The R is the decimal point, and you can see there's an omega right there.
That's not an omega, that's a D.
Okay, it's still 4R00, that's a 4 ohm resistor.
4R000D.
Okay, that's 3 zeros then, so it's that level of precision. But yeah, 4R, the R is the decimal point.
And if there was a different letter there than R?
It wouldn't be a different letter than R.
It's always R is the decimal point?
Yes, a precision resistor, they're going to put an R where the decimal point is.
Now, talking about... we'll save that?
We'll save that one.
Because that's a precision resistor.
Yes, it is.
All right, now we go to this.
Okay, these are power resistor. There's 100K at 100 watts.
Yeah.
So these were taken out of the HDL.
These are big ceramic wire wound.
Exactly.
These are serious.
On this one, you can see the windings. It's like trifiller. It's got 3 separate windings in parallel on here.
There's your word of the day.
Yes.
Trifiliar.
Trifiliar.
Now, sometimes you'll see these where it'll have a clamp around it.
That's called a tap, and you can basically adjust what your resistance is based on how long of the
And I've seen them with this, with the bumpy winding, and I've seen them like this, where it'll have a groove in it, and you can see the open wires in the groove, and you move that tab.
You move it where, yes, exactly.
Now, then we go to this great big thing.
Now that guy's
That's
beautiful.
sexy.
That is
pretty.
a name brand.
Ohmite, which is one of the big dogs in resistors.
Oh yes, very much so. But that's a 20 ohm, 5%, and I think it's I don't even know how many watts they're not saying.
A lot.
Ohmite 0131. And under that it's 75922, and then 20 ohms, 5%. That's gotta be.
And if you feel, you don't see it, but if you run your hand out, you can feel the flat spots on the top and bottom.
Yeah, for the winding.
Yeah.
So now, we could really go to town. Coming out of one of the transmitters I think you took apart.
This came out of a transmitter. It's a Ohmite power rib.
Yes.
They're in Skokie.
Skokie.
In case you ever wonder. This is 1 ohm.
There's a part number on it?
Yeah,
2412 or something?
2312 is the part number on that.
I Googled Ohmite 2312, and it'll go right to their webpage, and they got a couple of dozen different varieties of that.
Okay.
That is they don't give the wattage, but it's a 1 ohm resistor rated for 33 amps. Wow. So that's heavy duty.
This is 1 ohm, 33 amps. 30 amps, give or take, is exactly what one of our big Variacs is rated for. Okay, that's what it's rated for, but you got to go back to Ohm's Law to figure out what current you're going to dump through it based on what voltage you apply. So if I'm running a Variac through this at 240 volts, maximum 280 volts, at 1 ohm.
Volts. resistance of 1, so 240 volts divided by 1 ohm is 240 amps. It's rated at 33.
33.
Yeah, that wouldn't last too long.
It'd be pretty for a few seconds before it...
Oh, it
like,
would glow a
Yeah.
nice cherry red.
Now, then we go, do you want to talk about those or this?
Let's talk about this next.
Okay, so this doesn't look like all the others.
Yes, this is a little different. This is a current shunt. It's used in conjunction with a meter to measure the current flow coming out of something fairly sizable. You got 2 small screws here that you would mount or attach your meter leads to, and you have the 2 large connections that you would run your current through. And right on the side,
It says, ha, 50-50.
50 amp, 50 millivolt.
Okay.
Meaning, when you're running 50 amps through this thing, you will have a voltage drop of 50 millivolts across it.
So
the value of this is 1 milliohm.
So how the hell do they make these?
It's a precision process. They actually trim the width of the metal. Based on what the material is, they can calculate the resistance versus the length, width, and thickness.
Okay.
And they can actually trim this down and adjust it to get it
So
to
you
the
can pull
resistance
50
they want.
amps across that
You
all day
can pull
long.
50 amps across that all day long.
And it won't glow.
No, not at all.
Okay.
All right. And if you ran 1 amp through there, you would measure 1 millivolt across that. Now, I've built circuit cards that literally mount on those 2 center brass screws. That's a 1,000 to 1 gain amplifier. So when you run 1 amp through it, you get 1 volt out of that little amplifier, and you can measure that real easy with like an A to D converter on an Arduino.
Okay.
So you could measure, with that type of amplifier, you'd get 5 volts out of it when you were running 50 amps through it. Is that right? No, 5 amps through it would give you 50.
Okay.
But you could feed that straight into
But
an
this is,
Arduino and do
and they
current
make these in a
monitoring.
million different sizes.
There's
Like
a
you can
bunch
get
of
these that
different
you could
sizes.
run our whole building through.
Oh, absolutely.
Okay.
Well, the building is AC. That's for DC.
Okay.
All right. AC, you use current transformers, which is a whole nother.
Yeah, that's a different video.
Yes.
That's a fun video. All right, now what are the big boxes over here?
Okay, now, when you're playing around designing things, you may want to try a couple of different resistance values in things. And what this is it's called a decade box. And each knob is 10 times the other as you go up. The lowest setting here, as you turn the knob, you switch in. This has got a whole bunch of resistors inside. And as you change the selector here, the bottom one here is 0.01 ohms per step. So if I put it on a 5, that's 0.05 ohms. This spot here is 0.1, and then 1 ohm, and then 10 ohms. So you can get any value from 0 up to 11.11 ohms just by dialing your knobs
Okay.
in 0.01 ohms steps.
Now what's that one?
This one is about the same. Actually, I thought one was a higher range and the other lower. This one, the steps are 0.1, 1, and 10. So this is like the top 3 knobs out of this one.
Okay. And these are just used for testing and development and
Yep.
design.
And you put your leads on here, and as you turn your knob, you can dial up whatever resistance value you want to use.
Okay, now then we go up to this.
What do you got?
Well, this is for measuring. Now, this is my VOM, and it's got a selection on here with the omega.
Yep.
Okay, and that's my ohms. So
Yes.
I can take this and I can measure your little
Well,
50 milliohm things.
it's going to be, you're going to read 0 on that because it's such a
just
low
not that
resistance.
go.
It's not.
So this is
Here, measure that.
the way this, now tell them how this works.
Okay, what this does, even on the very old style meters, it has a power supply in it, a little battery, and it creates a circuit where you have a known fixed.
Currently not reading anything on there. It should.
Where's your nanofarads, mega ohms? I would expect you to be reading something there.
Weak. All right, tell them how it works. No,
No,
I wasn't getting a good contact. Now I got it.
now you got it.
All right, you tell them how it works.
All right, you're not getting good contact. I think you got bad meter leads.
Yeah.
Yeah. There you go, 50 ohms.
Okay.
Where were you contacting?
I was trying to get it out on this end.
You see the ceramic?
Yeah.
The ends here aren't connected to anything.
Tell them how it works, Paul.
Okay. Anyhow, the way this works is it creates something called a voltage divider. You have a power source, you have a known precision resistor. You put the precision resistor in series with what it is you're trying to test. And we got any room on the blackboard here? I'll do it up high. Let's see. You have a battery that's some known voltage. You have a precision resistor inside your meter. Then you go out through your test leads to some resistor out in the world. Come in through the other test lead, back to the battery. Now, you know what this resistor is. You don't know what that one is. So you got a known and an unknown. Well, your meter will measure the voltage across this resistor. It'll do it with something called an instrumentation amplifier. So you'll get a voltage across your known resistor. And it'll have the same thing, the same sort of circuit. I'll draw another instrumentation amplifier here. So you get a V sub K for voltage across the known, a V sub U for voltage across the unknown. You know what the resistor is because you built the meter.
And it's a very precise resistor.
It's a very precise, like 0.1 or 0.01%. And grind through the math, it's all Ohm's Law, but your resistance across the unknown is going to be mathematically derived from your known resistor here and your two voltages that you measure here.
Okay, and that's for a standard, little
meter. Now, this meter here has auto-ranging. What that means is there's more than one known resistor, and it'll select between them. It'll try it, and it won't work, and then it'll try a different one, and it'll like range itself in to get the best pull-up resistor that it has available. Other meters, you have to select which one you want to use based on the range you're measuring. And that's not going to work, is it?
It's not going to work. It requires high voltage leads.
Okay.
So
this one has three different four different ranges to measure.
But this is neat because this is a megger. And what a megger is a mega ohm meter. This measures massive resistances. Like if you want to measure things for like static electricity dissipation and things like that where you need
10 mega ohms or something like that.
But where this has that known resistance in the power supply.
It doesn't have the range.
Yeah, this puts out like a couple volts. I mean, this runs for years and years off a 9-volt battery.
Right.
This is much bigger because there's a lot more batteries in the bottom and it's got a higher voltage power supply, which is why if you look on this, and I'll see if I can get it where you guys can get a shot, it's got regular just ohms, and then it's got mega ohms with 100 volts behind it, and it pumps 100 volts down the wires.
Okay.
And then it's got 250 volts mega ohms, and then it's got 500 volts mega ohms, and then it's got kilovolts mega ohms.
So you're pumping 1,000. Your battery in that circuit up there is effectively 1,000 volts.
Yep.
To run the circuit.
And that's for crazy high resistances, and that's why there's two buttons on this thing for you have the red test button, and it's got special cables and that go with it. It's a whole thing. We just got these in. I haven't played with them yet. We're still learning about them. We do not have the cables, but I'm sure they won't be that big a deal to get.
Okay.
So I think that covers it, Paul. I think that's all the basics of resistors and the math and the theory and all that jazz.
I'd put the formula up for that resistance calculation. I just don't remember it off the top of my head. I'd have to dig a little.
Do you know the Wikipedia article for it? Do you know what it's called? Do you know the name of the formula?
Not really.
Okay.
I didn't know it had a name if it does.
We'll have to dig that up.
We'll have to dig that up.
All right. So you guys have fun. That's the basics of resistors. If you have more questions in electronics basics and concepts and theory and stuff like this, write them in, comment with your questions, and we'll make videos to answer them. It's what we're here for. Till next time, I'm Chris Bowden.
And I'm Paul Kidwell.
Please remember to rate, comment, and subscribe. And as always, I'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.